Okie dokes. We're going to be on page 21. So on page 21, we're going to continue our work with functions. I made a mistake on the earlier video, so I still got to do a bit of erasing. We're still going to work with functions and function tables and function rules, just to get us ourselves a bit more practice. We're also going to do a little bit more graphing. So we'll start off with some function tables. These ones we'll do together. There'll be some later that I'll ask you to try them on your own. So remember, the input, which is usually x, that's the number you're putting into the function. The output is like your answer almost, or the result. This right here in the middle of the function table is called a function rule. That tells you how you're going to get from the input to the output. So let's say the input was 0. That means that x, which is the input, is 0. So we do 3 times 0 plus 5 to get the output. Well, 3 times 0 is 0 plus 5. That would be 5. All right, let's try 3. Let's put 3 in there. That would be 3 times x would be 3 plus 5. Well, what is 3 times 3? 9. Plus 5 would be 14. Now let's try 9. So this is going to, bump up the output a little bit more because we're now dealing with a greater number. 3 times 9 plus 5. Well, 3 times 9 is 27. Plus 5 is a 32. Pretty good. All right, that was a two-step function because we had to multiply then add. This one's just a one-step function because all we got to do is subtract 4. So if the input is 4, we would do 4 minus 4. The output would be a 0. Well, if the input is 8, that would be 8 minus 4. 8 minus 4 is 4. So whatever we put in, we're just going to subtract 4 from it. 11 minus 4 would be 7. Perfect. All right, the next two we're going to do are kind of in reverse. We're going to go backwards. So in these ones, we get the output. We have to find the number that would go into the function to get the output. The rule here is whatever x is, we're going to add 2 to it. So now we're thinking, like, what do we have to add to 2 to get 2? Well, like 0, right? So 0 would be the input. If we do 0 plus 2, we would get 2. Well, what number would we have to put in to get 3? Well, the only number that would work would be 1. Because 1 plus 2 is 3. And what about 8? Well, to get to 8, what plus 2 is 8? That'd be 6, right? 6 plus 2. And like if we had the number like 25 here, the other way of looking at it is if you start with 25 and you subtract 2, that would give you the number that you start with. So if you kind of go backwards in a way, because then 23 plus 2 would be 25. Nice. All right, let's try this one here. This is number 4. We got a two-step one going backwards. So we have the output. We're trying to find the input. So we're thinking, like, what could we multiply by 2 and then add 4 to get to 18? Well, let's try, I don't know, like 5 maybe. 2 times 5 is 10 plus 4 would be 14. So not 5. What about 6? 6 times 2 is 12 plus 4 would be 16. So it must be 7. Because 2 times 7 is 14. That'd be 14 plus 4 would be 18. Look at that. Okay, so then what would we have to put in to get to 22? What about 8? The next number. Let's try 8. 2 times 8 is 16 plus 4 is 20. So it's not 8. What about 9? 2 times 9 is 18 plus 4 is 22. So we'd have to put in 9 into the function to get 22. So the input would be 9. The last one, 34, seems like a lot greater. So another way to think about this is We subtract 4, because we have to add 4 at the end. We have to get to 30 somehow. 2 times 15 would get us to 30, plus 4 would get us to 34. So 15 would actually work. 15 would be the number we'd have to input to get 34, because 2 times 15, that's 30, plus 4, and that would be 34. Okay, we're actually going to skip this one here about the cupcakes, just because the graph for this is actually not linear. It's not a straight line, so we're going to skip this one. And we're going to go down here and talk about Bella. It says here that Bella rollerblades 8 miles in 1 hour, or 8 miles per hour. The function, I'm just going to zoom out. The function rule that represents this situation is 8x, or 8 times x, where x is the number of hours. So no matter how many hours she rollerblades, you would multiply that by 8 to get her total distance. It says, make a table to find how many hours she has skated when she has traveled 16, 24, and 32 miles, then graph it. So you got to be careful with these numbers, because these are miles. So we wouldn't put it under hours. These are not the input. These numbers are actually, it looks like, the output. The miles would be 16, 24, and 32. So now we have to figure out, well, if she went 16 miles, how many hours did it take her? Well, we're thinking like, what would we have to multiply by 8 to get to 16? It would probably be 2. So in 2 hours, she would have gone 16 miles, because 8 times 2, 16. Well, how many hours would it take her to go 24 miles? That would be 3, because 8 times 3, so we're going backwards here. 8 times 3 is 24. And then what would we multiply 8 by to get to 32? That would be 4. Because 8 times 4 is 32. Now, this here again is an example of what's called a linear function. It makes a line. It makes a line. So when we graph this, we should see that it creates a line when we graph it. Let's see if that happens. All right, well, it looks like here the input is hours, the output is distance. Normally you're going to find this is the x-axis, so this is going to be the input, x. And this is the y-axis right here. We're going to have the output here, y. So 2 hours, she can go 16 miles. So we're going to put point there. 2 hours, we're going to go up to 16, which is going to be and it's hard to see, but slightly above 15. Okay, and the grid is kind of hard to see there. I apologize. 3 hours is going to go up to 24. So 24 is going to be slightly below 25, like right there. And then 32, 4 hours is going to be 32. So at 4 hours, she can go 32, which would be like right here. So that seems like it is making a line. I'm going to put 2 more points in there. Now, they're not on the chart, but after 1 hour, she would go 8 miles, because 8 times 1 is 8. So I'm actually going to put that point in there as well. And another point we can actually put in is after 0 hours, she would have gone 0 miles. So you can see by putting those extra points in, I'm just going to get a ruler real quick. You can see that if we were to connect these points, they'd make a line. So that's linear. That's called a linear function because it makes a line. Okay, that's a nice graph. Okay, so let's go to page 22. And this one here, if we would have done the cupcakes one, this would not be linear. This would not be linear. That would be curved or nonlinear. Okay. So on this page here, okay, I want you to try these 12, 13, 14, 15. I want you to try these input-output tables on your own. Okay? After you do them, at the end of the video, there's going to be I'm going to post a picture of the answers in the assignment. So when you're done with these 4, go back into the assignment and check your work to make sure that your answers are the same as mine. So what you could do is either pause it now and try these, or try these at the end. But make sure you do these 4. I'll be looking for those as well when you show them to me in class. So either pause it now, or we'll keep going and you can do them at the end. It's up to you. So we're just going to do a couple more graphs. Doing a couple more graphs here. This one is about Ricardo. Let's see what's going on with Ricardo here. Ricardo weighs 2 pounds more than twice his sister's weight. Well, that's an interesting situation. The function rule, 2x plus 2, where x is his sister's weight, can be found or used to find Ricardo's weight. So that means, like, if you take his sister's weight, you double it and add 2 pounds, that will get to Ricardo's weight, because he's 2 pounds more, that's the plus 2, than twice his sister's weight, that's the 2 times. Make a table of values to show Ricardo's weight when his sister is 20, 30, or 40 pounds. So this is his sister's weight. These numbers are his sister's weight. There's the column for his sister. So this is where we're going to put those numbers. So these are the inputs: 20, 30, and 40. So these are the inputs. Let's try this out. So this is a little easier because we don't have to go backwards. We're going to multiply by 2, then add 2. So if the input is 20, we're going to do 2 times 20 and then add 2. Well, what's 2 times 20? It would be 40, plus 2 is 42. So Ricardo weighs 2 more pounds than twice his sister's weight. Twice his sister's weight is 40, plus 2 would be 42. That makes sense to me. And then 2 times 30, this is the next one, plus 2. If Ricardo weighed 30, or his sister weighed 30 pounds, 2 times 30 is 60, plus 2 would be 62. Okay? And then, if Ricardo weighed 40, or sorry, his sister weighed 40, 2 times 40 would be 80, plus 2 would be 82. So we're doubling it and adding 2 each time. Now, it was easy again because we started with the input, then we got the output. Let's graph it. Let's graph it. Here we go. Hopefully you can see the whole thing here. All right, so here's our graph. On the bottom, of course, that's the input. It's the x value. Here's the y. That's the output. Ricardo's sister, if she weighs 20 pounds, he'll weigh 42. So here's the sister's weight. She weighs 20 pounds. I'm going to go up to 42 for Ricardo. 42, again, is going to be a little bit above 40, like right there. So again, this should be linear again. This is called a linear function. It should make a line. In 7th grade, you'll work more with what are called nonlinear functions that curve. 30 pounds. If his sister weighs 30 pounds, he weighs 62. So if she weighs 30 pounds, we're going to go up to 62. There it is. Nice. And if he weighed, I'm sorry, I keep mixing them up because we never got her names. That's the problem. If she weighs 40, he'll weigh 82. So that's the next number we're going to graph. We're going to go down to 40 for Ricardo's sister. Then we'll go up, right up from that to 82. That looks pretty straight to me. Now, I'm just going to add one more point. Well, actually, I'm not going to add that point. So I'm going to actually connect these. This one's actually not going to meet up with 0. Okay? And the reason, you'll see it doesn't meet 0, because if she, for some reason, and of course this would happen, if she weighed 0 pounds, you might think that he would weigh 0 pounds. But according to this function, 2 times 0 is 0, plus 2. If she weighed 0, he'd actually weigh 2 pounds, which is kind of weird. So I'll put that in there. I added that little point, or actually that point would be like right here. If she weighed nothing, he'd weigh 2. And that wouldn't really be real, but according to this function, that would be true. So if she weighed 0 for whatever reason, it'd be 2 times 0 plus 2. Well, 2 times 0 is 0 plus 2. He would weigh 2 pounds. So that's why it doesn't meet up at the bottom here, because because of that. So it's still linear, though, because it's making a straight line. All right, last one we're going to do together. Then, of course, if you didn't do those ones up top yet, make sure you try those out. The Quinn family drove at a rate of 55 miles per hour. The function rule that represents this situation is 55 times x, where x is the number of hours. Make a table to find how many hours they have traveled when they have driven 165, 220, and 275 miles. So this is miles. We're talking miles here. So that would go in the miles column, which is, this is, of course, the output. We're going to have to go backwards and find the input. So, of course, this is the input. This is what we're trying to find. So we're thinking, what would we have to multiply by 55 to get 165? I'm thinking it's going to be like 3 because this is close to 50. And 50 times 3 is 150. So if we multiply by 3, it should be close. I'm just going to double check that right here. 55 times 3. 5 times 3 is 15. 5 times 3 times 5 is 15 plus 1, 16. So that works out. That checks out. So 3 hours would put them at 165 miles. That's going to be 55 times 3. How many hours for 220? That's 55 more miles. So that would be 1 more hour. Because 4 times 50 is 200. 4 times 5 is 20. Add those together, you get 220. So this is going to be 55 times 4. Last but not least, this should be 5 hours because 5 times 50 is 250. 5 times 5 is 25. 250 plus 25 would be 275. So that would be 5 hours. So we did 55 times 5. That would be it. All right, let's graph it. Now, you'll notice in this graph, it's kind of neat, it has this little squiggly here. Now, that squiggly means that we skipped from 0 to 75 because it's really important that this, what's called the scale, that's the number the graph goes up by, the axis goes up by, is the same each time. This goes from 0 to 75, but then counts by 25s. You notice that. So the reason why there's that little jagged edge there is because we skipped right from 0 to 75 and then counted by 25s. Because if you look at these numbers here, there's not any like data between 0 and 75, or really 0 and 100 or 150. So they decided to skip some numbers to make the graph less long, I guess. It would be really tall if we kept those numbers. All right, so 3 hours, 165 miles. This is a little tough because they count up by 25. So 3 hours, 165 is going to be closer to 175, like right there. And again, we can tell kind of if we're right if it makes a line at the end or a diagonal line. 4 and 220. So 4 hours, 220. That's going to be closer to 225. Okay. And then 5 would be 275. There's 5. Oh, 275 is right there, right on the mark, right on the money. Now, if you connect these, like it's not going to, I mean, this one's kind of tough because it's got that little jagged, but if you put a line from there, it looks like it's going to be straight. It's going to be linear. And again, this wouldn't meet up at 0 either because, again, this graph was, it's called truncated. It was lessened. You don't have to know that word, but it is linear still. Okay, so at this point, if you haven't finished these, try them out. If you have, make sure to check your answers on the assignment. All right, have a great day, and I'll see you next time. Bye-bye.